This video looks at half equations, which is higher level stuff, but that doesn't mean it's necessarily harder. It just means you should probably understand the basics first. So before you have a go at half equations, make sure for normal simple equations you understand how we make simple equations, why we have to balance them, and how we balance them. And then you'll be able to have a go at half equations. And the key difference is half equations just show part of what's going on in chemical reaction. They'll focus on one ion and show electrons. So you will also need to be familiar with ions, how we use the periodic table to find the charges of an ion, and I've made a separate video on that as well. I also, in a video I made about metallic bonding, made a half equation. I didn't say that that was what I was aiming to do, but I did this just to show that if we had a sodium atom, a metal atom, then it would lose electrons to become a positive metal cation, positive sodium cation. And what I made there in that equation that shows that happening is a half equation, because it just shows one ion and the electrons that balance it. They're just like normal simple equations in that we'll need to balance them. And the first thing we need to do is balance the atoms. And once we've done that, because these show charges, we need to balance the charges. For normal reactions, we don't need to do that because they don't show charges, but half equations do. Okay, first example I'm going to use is if we started with aluminium cations and made just aluminium atoms. So we're starting with the cations. If we look at our periodic table, we can see, because it's in group 3, that it's Al3+. And that goes to make aluminium without a charge. What's happening there? Well, in order for it to have gone from a cation to just the atoms, it must have gained electrons. So we're going to show it gaining electrons in this. First of all, let's balance the atoms. There's one aluminium atom here, ion, and there's one here. So that's all sorted. Now I need to balance the charges. We've got a 3+ charge on the left side and no charge on the right hand side. I'm going to balance the charges by adding electrons, and because electrons are negative, I'm going to add them to the side of the equation that's positive, or that is less negative. So this is the positive side, so I'm going to put my electrons in here. An electron always has a charge of 1-, so I always show it as a little e with a charge of just 1- there. But aluminium ions have a charge of 3+. So to balance out that 3+, I need 3 electrons. Notice I'm not putting the 3 there as a little 3, because the charge has got to be 1-. It's always 1-. But to show that there's 3 of them, I put a big 3 in front, just like balancing equations. Now that's balanced, and as I said, it shows the aluminium cations gaining electrons because they're being added onto it and making the aluminium metal. So that one's done. Another example, if we've been asked to show chloride ions making chlorine gas. Now from our periodic table, chloride ions have a charge of 1-, so that's going to be shown as Cl-. And we know that chlorine gas is Cl2, it's diatomic, always exists in 2s. Okay, now we need to get our electrons in to balance that out. First thing, let's balance the atoms. 1 chlorine here, but 2 on this side. So I'm going to need to make sure there's 2 here. I can't add a little 2 there, remember. I'm balancing, so I'm putting big numbers in front. So I'm going to put a big 2 there. So I've balanced the number of atoms now. Next step, I need to balance the charges by adding in my electrons. I'm going to add the electrons to the side that is got the positive charge on, or that hasn't got the negative charge on. There's no positives in this one, but because this side's already negative, I'm going to put the electrons on this side. Now, there's 2 lots of 1- charge here, so there's a total of 2- charge. So for it to be balanced, I've got to have 2 lots here, so I'm going to put a 2 there. And now we've balanced the charges, 2- to 2-, and this shows that for chloride ions, to make chlorine molecules like that, they have got to lose electrons. We show that by the fact that the electrons are now separate. So that's another example. The last thing I'll show you is we could take a full symbol equation for reaction, and we could make a half equation from part of it. So if I had the reaction of a piece of magnesium metal reacting with hydrochloric acid, it would make magnesium chloride, give off hydrogen gas. It's a classic reaction. If we wanted to show what happens just to the magnesium as a half equation, we need to look at the charges involved on the magnesium. Now at the start, it's by itself, so there's no charge there, just Mg. But here in the products, it's part of an ionic compound, so it's going to be charged. And we know that the charge of chloride will be Cr-, and there's 2 of those. And the charge of the magnesium is Mg2+, because it's in group 2. So the magnesium is going from being Mg to Mg2+. Now, how has that happened? If it's going to become more positive, it's got to do that by losing electrons. So that's what we're going to be showing. First of all, let's balance the atoms. 1 to 1, already balanced. Second of all, let's balance the charges. We've got 2+ here. We're going to need to balance it out. Remember, we put the electrons on the side that's got the positive charge on. So there's my electron. It's a 2+ charge, so it needs 2 electrons to balance. So I'm going to put a 2 there. So now I've made and balanced the half equation that shows that in this reaction, what is happening to the magnesium specifically is it's losing electrons to make Mg2+. So there's 3 examples of making half equations.